Hi everyone and welcome back. I'm Neo and today we're diving into the first lesson of our course. We are kicking things off with the 101.1 module which focuses on determining and configuring hardware setting in the world of Linux. I'm not going to lie, LPIC starts with one of the most challenging topics in the Linux, but don't panic, I know we can wrap our heads around this together. The weight of this module is 2, so they don't expect us to become hardware gurus overnight. Think of it this way. Maybe you've just handed the keys to a Linux system at work. You're not building it from scratch, but you need to know the lay of the land. As a Linux admin, getting cozy with the underlying hardware is part of the territory. By the end of this module, we'll be able to enable and disable integrated hardware components, distinguish between types of mass storage devices, understand what resources each device uses, using tools to list and manipulate devices including those connected through USB, and understand sysfs, procfs, udev, and dbus. Now I know this might seem like a lot, but trust me, we'll break it down step by step and it will all start making sense. But before we dive into these objectives, let's go over a few key terms and concepts. First up, what exactly is hardware? In simple terms, it's all the physical components that make up a computer system or run within it. When you want to run a software like a program or a game, your operating system needs to talk to your hardware. But here's the thing. Hardware has a firmware, a kind of behind-the-scenes manager that handles the hardware settings. When you first power up a computer, there is a small window before the OS loads where you can access firmware configuration settings. Most systems offer a configuration utility that can be executed as the system is turned on. Until the mid-2000s, the configuration utility was implemented in the BIOS, Basic Input-Output System. But today most newer systems run UEFI or Unified Extensible Firmware Interface instead, which has more sophisticated features for identification, testing, configuration, and firmware upgrades. You usually configure settings by using either BIOS or UEFI firmware. We often use the term BIOS setting to refer to both. You can access BIOS settings when you turn on your computer. Usually you do this by pressing a key such as Delete or F2 after turning on your computer but before the operating system load starts. In BIOS Setup utility, it's possible to enable or disable integrated hardware components, active basic error protection, and change hardware settings like IRQ, interrupt request, or DMA, direct memory access. Changing these settings is rarely needed on modern machines, but it may be necessary to make adjustments to address specific issues. There are RAM technologies, for example, that are compatible with the faster data transfer rates than the default values, so it's recommended to change it to a values specified by the manufacturer. Some CPUs offer features that may not be required for particular installation and can be deactivated. Disabled features will reduce power consumption and can increase system protection, as CPU features containing known bugs can also be disabled. If your machine has multiple storage devices, it's crucial to define which one has the correct bootloader and should be the first entry in the device boot order. If the incorrect device comes first in the BIOS boot verification list, it could lead to the operating system not loading properly. PCI and sockets. Back in the day, if you wanted to upgrade your system's memory or graphics, you had to buy a whole new system. But mainboards came to rescue. Now you can see sockets for CPU, RAM slots, PCI slots, allowing you to boost your resources and expand your system. In this picture, you can see these sockets on the main board. USB. Another way to expand your system is via USB ports. Over the years, we had many versions and types of USB. As you can see in the picture, each one had different shapes and speeds. For example, on USB 1, the speed was 1 megabit per second. On USB 2, we had 480 megabits per second. And on USB 3, it's 20 gigabits per second. You can see the improvement with each generation. Nowadays, we connect storage devices, network adapters, or many other devices via USB. GPIO, or General Purpose Input-Output. Another connection that you should know about is GPIO. While main boards on your PC don't use this type of connection, microcomputers or single-board computers like Raspberry Pi have them, as shown in the figure. GPIO is a standard interface to connect microcontrollers to another electronic devices, such as sensors, diodes, displays, and stand-on-chip modules. These pins on your board can connect to another devices, each performing a specific process. For example, a pin can connect to a temperature sensor, and when temperature reaches a certain level, the board starts a fan. Now that we talked about BIOS, firmwares, hardware components, and connection types, let's talk about virtual files for hardware and system information. Several virtual file systems provide an in-memory look at your system as the kernel sees them. These file systems are virtual, meaning no real files exist on storage devices. Instead, they provide an insight into kernel data structure and your system hardware. sysfs and sysdirectory. Now that you know about the virtual file systems, or as some call them, pseudo file systems, let's learn about sysfs. The sysfs file system is a pseudo file system that provides an interface to kernel data structure, created when system boots up and vanishes when system restarts or shuts down. The files under sysfs provide information about devices, kernel modules, file systems, and other kernel components. Sysfs introduced to specifically store system information and its components. To see a list of sysfs file systems, open your terminal and type in ls/sys. We're not going to spend more time on this file system, but you should know all the block devices are at block, and bus directory has all the connected PCI, USB, serial, or other devices. procfs. Proc file system is a virtual file system created on the fly when the system boots, and it's dissolved at the time of system shutdown. It's sometimes referred to as a process information pseudo file system. It doesn't contain real files but runtime system information. It contains useful information about the processes that are currently running. It is regarded as a control and information center for the kernel. The proc file system also provides a communication medium between kernel space and user space. This is where the kernel keeps its settings and properties. This directory is created on RAM, and files might have write access. You can find things like IRQs or interrupt requests, I/O ports, the location in memory where CPU can talk with devices, DMA or direct memory access, processes, network settings, and so on. If you want to list procfs file system, just type in ls/proc. The numbers you see in your list are process IDs. There are also other files like CPU info, mounts, and mem info. Let me show you CPU info. Just remember, because proc is a RAM-based file system, all these changes will be reverted after a boot. You have to write into config files like ETS to make these changes permanent. We're going to learn about the ETS directory later on. Remember to do the commands on your system and see the results. That's it for this video. On next one, we're going to continue 101.1 module. Thanks for watching this video. If you like it, please subscribe and recommend this channel to your friends.